Hello everyone, my name is Mesut Durukal. In this session, we will a little bit talk about using machine learning in software testing activities. And I love to go to Summit, and I'm very happy to be a part of this amazing conference. So I want to start with a huge thanks to everyone who made this happen, including the awesome sponsors. And before moving forward, let me a little bit introduce myself. I'm a software test engineer, and most of my colleagues most of my time I'm spending on test automation because nowadays test automation is an important part of the whole quality assurance activities. But of course, not only the automation, but a lot of quality assurance initiatives we are trying to initiate to improve the quality in both the products that we are developing and the practices or the workflows that we are following to develop those uh, products that we are delivering to the customers. So machine learning usage is a part of these improvements as well. So we will discuss in detail. But in general, in my background, I have almost 15 years experience in both API and UI testing in lots of different domains and testing lots of different aspects of the quality of the products that we are developing. Apart from that, personally, I'm interested in football and I'm a huge Galatasaray fan. And I'm leaving some socials here. Please do not hesitate to reach out or get connected. And this will be the brief agenda for today's talk. I want to start with a quick reminder of the machine learning algorithms, how it works, and what are the working principles. And basically, why do we need? Why are we talking about using machine learning in software testing activities? What are the biggest challenges in software testing and how they relate to the integration of machine learning? And then we will talk about in the second part about using machine learning in different stages of software testing lifecycle because there are lots of different opportunities to use machine learning. We can do several things like maybe generating the test cases or even implementing the test code or maybe doing the maintenance activities, continuous maintenance. So we will discuss what we can do in different stages in the whole software testing lifecycle one by one. And eventually, at the end of the slide, I will share an example, a practical example, what I tried in my real life project, which was the classification of the bugs that were raised in the project and trying to do the bug triage with the help of machine learning algorithms. So let's get started. Why are we talking about machine learning integration in software testing? Because we really need it. We need some help, we need some support because we have lots of different challenges. Why? Because nowadays software testing is becoming more and more difficult. We are testing lots of different complex and complicated applications. They are deployed in several platforms. We are not testing in only one execution environment, but lots of them. For example, whenever we are testing a web application, it's not only one browser or it's not only desktop version, but also mobile version and several browsers as well. And similarly, for the other applications, they are communicating to different applications as well in the whole platforms, in the whole environment. So we are testing several integrations and interfaces. So it makes the scope really huge. And on top of this huge scope, the comprehensive scope, we have a very limited time. Nowadays, we are not having seasonal releases. Like I remember in my early career, we were having like a release or a deployment this summer, and then the next will be maybe 3 months, 6 months later. But nowadays we are deploying every day, right? So we are doing the continuous testing activities. The time is very limited, and we have to implement or automate our test cases immediately just after the development is done. In that case, we can do the regression test in an automated manner, and we don't lose too much time for manual testing activities, and we can reserve the rest of the time for the exploratory testing and other quality assurance initiatives. And of course, there are some different constraints as well. So there are lots of different challenges. And it looks a little bit scary, right? Because there are too many difficulties and it looks desperate. But of course, these challenges enforce us and encourage us to improve our activities and to widen our horizons. So machine learning usage is one of them. So can they really help us? Maybe we can think about machines or robots or these kind of algorithms as a potential assistant to us. Can they assist our processes? Maybe we can leave some of the activities to them. They can already implement or develop or build some processes or approaches automatically, and then maybe on top of that we can do the final regulations. So this will be our final discussion during the talk. Maybe can we replace some of the activities, or maybe at least can we get some support from the machines. Actually, we can already see that they are helping us a lot in our daily life, right? For example, whenever we are using our smartphones, smart devices, whenever we're even using TV, we are seeing there are lots of different machine learning or the artificial intelligence activities, or the programs or the applications that are helping us. Whenever I'm searching for some articles and I'm reading them, then I see some recommendations, some related articles related to my query or the search. So, and even regardless of my search, sometimes they just recommend me some articles that I might be interested in. How? Because the machines know my habits or my interest areas. They know me very well. Like sometimes I'm seeing on my mobile device that I have to leave to catch up the train to go to the office, because it knows generally what time I leave home, and of course it can check the situation of the traffic jam or the other constraints. So uh, summing all up, of course machine learning is a great potential to help us, because normally as a human my resources are limited. I cannot check all kind of data at the same time, but of course machines can check lots of different APIs in the meantime and process data in a very limited time. For example, whenever we are talking about solving a difficult problem as a human, as a uh, in terms of the manual effort, it might take some time, but for the machines, it can take maybe only microseconds, very tiny timings. So it's a great potential, and we maybe should search ways to utilize this great potential in our software testing activities. But we will see how it works. But first of all, let's all remember quickly how it works. Of course, for the machine learning algorithms, data is very important, because first of all, the training happens. So the machines train the model, they build a model on top of all the observed data. First of all, it observes how the system works. The input data is coming to the system, and the system somehow reacts to input and generates the output data. So the model, after some time, tries to predict what kind of input data is reacted with what kind of responses. So this is already a generated model, and after the model is mature enough, we can already use it to predict the responses to the upcoming input data. And if the performance is not satisfactory, then we can of course update or modify our model. But otherwise, if it is already satisfactory and we can use it in our activities, then we can go with the models that are generated after training the machine learning algorithms. So let's see how we can use machine learning in software testing lifecycle. This is the ordinary software testing lifecycle, starting from the analysis of the system, like analyzing the requirements and the specifications. And then after we learn the system very well, after we know what are the expected behaviors or the expected results on top of our user actions, then we have to design some test cases to cover these expected requirements or behaviors, to cover the specifications. So normally in software testing, we perform test steps. In each step, we have some user actions, and we collect the actual results. How our user actions end up in what kind of behaviors. And then normally we have expected results for each of these user actions. So what we do is in software testing, we try to match if the actual result is meeting with the expected result. If not, maybe there are some deviations, so it might be some bugs, some issues, or at least it might be some improvement areas, improvement rooms. But otherwise, if they are simply matching, then we can say that the test is passing. To ensure that, to ensure all the expected behaviors are met with the development activities, with the implementation of the product, we design our test cases. There are lots of different test design techniques, like including the boundary value analysis, or maybe equivalence partitioning, or several other techniques. But eventually, we have to build up a good test suite which is covering the correct scope and covering the critical behaviors and the expected results. And after we design test cases, what we do, of course, we execute them to see if they are passing or failing. And how can we execute them? Both in manual ways or the automated ways. And if we tend to automatically execute them, of course, we have to implement test cases to let them run in our CI/CD pipelines. And that should be the priority nowadays, as we discussed in the beginning, because without test automation, it would be really very difficult to run the test cases manually every day, again and again. So if we just automate and implement the test code, we can just create some jobs to trigger them, to trigger those executions, and even the evaluation of the results can be done automatically, and even the report we can do by calling the interfaces of the issue tracking systems that we are using. So we can create some dashboards and we can report these results to the dashboard. And after the executions, we can do the troubleshooting. Like we can analyze the test results and try to understand if everything is executed properly or if there are some issues that we have to investigate. And of course, after the execution, the investigation is a part of continuous maintenance. But if there are some issues in the test itself, because sometimes the failures stem from the issues from the product, but sometimes not from the product, they are not real bugs, but they are false alarms. So it means there may be some issues from the test code itself. We may have some test smells in our test automation frameworks. So in these kind of situations, we have to apply the fixes to our test code. We have to maintain and we have to heal the failing test code. So self-healing will be another topic that we will discuss, which we can do by the help of machine learning algorithms. Actually, all of these stages, we can somehow use machine learning. So we will discuss each of them one by one. Let's get started with the first one. After we analyze the requirements and the specifications, we can generate some test cases to cover those specifications. So how can we do that? With the help of machine learning. For example, let's get started with an API example. On the slide, I left an API entity, which can be a body of a post request or like the body of a response, basically. So here I have a library software. So in my software application, I can query the books which exist in a library, or maybe as an admin user, I can update the database in the library, so I can add some more books. And each book have some different attributes. Like I can add the information for its ISBN number, or the author information, or the publish year, or the price of the book if someone tries to buy it. So what I can do is maybe I can perform some get queries to get a list of all the books which is meeting with my filter, or get a specific book by passing some ID or the name of the book, or otherwise I can perform some post queries or put queries to add a new book. So what machine learning can do is, or the machines can do is, to develop a machine learning algorithm just to observe the request and the responses. For example, what happens if I send a bad format request? Like uh, I already can observe by seeing all this data, all the requests and responses. I can already see that I need some specific format for the ISBN number, right? For example, first of all, a number, and then a dash character, and then 3 digits and another dash character. So there is a specific format. What happens if I send another format, or maybe a broken format? Or I already can see that the price is expressed with some double values, and the year is some maybe string value or just a number. But of course it should not be a minus, right? Because or similarly, the price cannot be a minus value, because a price should be something positive. So what happens if I send all these kind of values? So normally in my training data, if I already perform these requests, and if machine observe that when I send a bad format request, I get a 400 response coded response from the system. Or maybe when I send an unauthenticated request, like maybe or unauthorized request, like without attaching the tokens or without entering the credentials, what kind of response codes I have. Like maybe it would be 403 or 401. So machine can observe all these kind of uh, requests and the reactions from the system. So it means it is already generating the model. And afterwards, after seeing all these kind of requests and responses, after observes all these behaviors, then for the upcoming responses, it can already predict. Like in another endpoint, if I send another request without an authentication, then it can guess that for the other endpoint it was 403. So for this one, it would be also 403 because it's a similar request which is also unauthenticated without having or attaching the tokens to the requests. So all these kind of observations will help machine to build their model, and we can develop our algorithms in this way. But of course, we have lots of several options and alternatives nowadays. For example, when I describe my problem or the user scenarios to ChatGPT, then it generates lots of different test scenarios. And when I see the generated set, I can see that all the positive and negative values or negative cases or the corner cases, the boundary conditions are also evaluated. And if I'm not satisfied with the response, I can further ask some more questions and I can try to improve the response. But eventually, I can say that it helps me a lot to save some time to think about or designing some different test cases, and at least I can use the test cases generated by the machine learning algorithm, and on top of that, of course, I can improve my suite as well. And after I generate my test cases, how I continue with my software testing lifecycle, I should implement the test code to be able to execute them automatically, to automate them, and to let them run in CI/CD pipelines. So how I should do that? Of course, first of all, I have to understand the problem. What kind of expected outcome data should be generated on top of the test data or the user data? So we have the input data, and the outcome or the output data should be generated with the algorithms that we are developing. So first of all, we should understand what kind of operations should be performed on the input data to end up with the expected outcome. So for us, for human beings, it is not a really very easy problem, but for machines, they can solve in a really very short time. So for example, on this example on this slide, we have a series of input data and we expect an outcome or output data after applying some operations on this. So figuring out what kind of operations we need is not a very easy problem again for us, but for machines it can be solved in like microseconds, milliseconds. And we can see that for this example, like all the values are multiplied with 4, so multiplication by 4, and after that filtering out all the positive values, leaving only the negative values, and eventually sorting from biggest to smallest would be the operations that we need. After figuring out these kind of this series of operations, just applying the relevant code is not difficult, because when the input is there, we will just multiply by 4 and we will apply some filtering and sorting algorithms. That is the easy part, but the difficult part was already figuring out all the operations that we need. So in this way, again, we can figure out what should be the operations uh, after observing the input data and the reaction of the system. Then it is again a way of generating the model and applying the same model to the upcoming data. But of course, again, we can talk about the use of different platforms like ChatGPT or OpenAI. So we can basically just describe our problem and they can generate the code as well in a very short time. For example, on this example on the slide, I'm asking them to generate a code. In this case, it was a Python code to perform a test scenario in which I navigate to google.com and perform a search and then continue with the relevant steps. And when I see the code, it is really very similar to what I would implement as a software tester, as a human tester. And another example, not only with only certain programming languages, but by using some different E2E test automation frameworks, we can ask them to generate some code. For example, in this example, again, I'm asking them to generate some Cypress code, which is navigating to a certain website and performing some queries. And when the results are shown on the page, do some assertions. So I can see that the code is generated very properly. And again, even if I'm not satisfied, I can ask to further improve the part of the code that I want to modify or update. And when we are talking about test automation, of course, especially the UI test automation engineers would know it very well. Sometimes the locators or the selectors that we are using to select the elements on the page are sometimes broken, because sometimes the layout of the pages are updated by the developers, or there may be some other changes in the design of the web pages. So whenever they apply these changes, our locators or the selectors are broken, so we cannot find the elements as before anymore. So of course, rather than using traditional locators like XPath or CSS or the class name or the maybe some other attributes, of course we can introduce some unique IDs. But there is one more thing that we can do, which is trying to locate the elements visually, right? For example, whenever as human testers we are executing our test cases, what we are doing is just to locate the elements on the page. For example, whenever I'm typing some queries in a keyword or a text field, then first of all, I find where the text field is. For example, it is maybe on top of the page or somewhere in the middle or at the bottom. So I locate visually. But when we are trying to automate this, we pass some locators. Find this element with a specific key attribute. But again, whenever we are doing the automation, we can do the visual recognition just as we do as human testers. So for this case, of course, we can use lots of different images or icons to relate with the element that we are looking for. So for example, this is a open repository taken from test.ai, I guess. So there are lots of different images or icons used for specific purposes. For example, if we are testing an online shopping site, there would be some online shopping carts, and a basket icon or any similar icon can be used in lots of different applications or different websites. So we can train our model, and then in our website, of course, it tries to find the online shopping cart whenever we are performing our test steps. And after the implementation is done, what we do next is to execute these test cases. During the execution, we can collect lots of different data, and whenever we are talking about data, of course, we can talk about the integration of machine learning or the artificial intelligence as well, because whenever we have some data, we can have some hidden patterns underlying, so we can figure out those kind of patterns, and we can develop our model to predict the upcoming data. For example, maybe we can collect the execution duration for each time, and then we can perform some average measurements, and then we can try to predict or maybe try to figure out the anomalies for the upcoming executions. For example, after a number of executions, if I see that my suite finishes maybe in 5 minutes or around that in average, and in one of the executions after that, if I see that the execution did not finish in even 15 minutes, then obviously there is a problem, right? So the machine learning can already notify the tester that my observation for the previous execution was the execution duration was maybe 5 minutes, 6 minutes in average, but this time it finished in 15 minutes. So there might be some issues. Some test cases might have some problems, or some responses from the maybe the servers or the product was being responded late. So please go and check. So these kind of notifications will help us a lot to make our troubleshooting and analyzing the execution results. And of course, not only the execution duration, but also lots of different data we can collect. And after collecting all this data, we can perform several activities. And self-healing is one of them. Like we can collect all the screenshots, and after building our model, in one of the executions after that, if the screenshots do not match with the previously taken screenshots, then we can evaluate if it's an intended change or maybe a failure, like maybe the image is simply not loaded, or maybe is replaced with some unintentional images. So in these cases, we can the machine learning can recommend the proposed solution to maybe to fix the locator or the selector of the image, maybe because it is moved to another location on the page, right? Or maybe under another class in the page. So it can already recommend to apply the fix, but otherwise at least we can locate the problem of the failure, and then we can easily fix our code. And of course, not only self-healing, but the code review is another type of continuous maintenance that we can do in our test automation framework, because we can always refactor or always improve our test code. So if somehow we can teach all the best practices, or even the entire patterns that we should avoid in our test implementation, then the machines can perform the code reviews on behalf of us, right? For example, whenever we teach them using some embedded or magical numbers, hard-coded numbers inside the code is an anti-pattern that we should avoid. And then whenever we let the machines review our code, whenever they find some magical numbers or hard-coded values, attributes, they can notify us. You taught me that this is an anti-pattern, and now I figured out there are some issues that you have to fix. So the code review is already done automatically in a very short time. Because otherwise, what we would do is maybe, of course, we can utilize some static code analysis tools as well. But eventually, we would do the peer analysis, and whenever they find some issues, they will send the code back to us to apply the fixes, and it will be a few rounds. But in this way, we can already fix most of the issues in the first place, and then we can send for peer review, and we will save a lot of time, I guess. So we already discussed about self-healing. After locating the point of failure, then we can apply our fix easily. And one more thing that we can discuss in terms of, in regards of the continuous maintenance, is sometimes we have to migrate our code from a test automation framework to another one, or maybe sometimes even we might change the programming language that we are using in our test automation framework. So these kind of migrations can be done again with the assistance of machine learning, because again, it already has a lot of training data, and which code relates to what other in the other frameworks or the other programming languages is known by the machine learning algorithms, and it can be easily done. And maybe even if there are some points that we have to update, of course, it will help us to save a lot of time. And with a minimum or minimized effort, we can complete our migration from a test automation framework to another one, or even from one programming language to another one that we are using in our test automation frameworks. And of course, sometimes during the execution, we find some bugs, we find some issues, right? And we report them. So to manage all these kind of issues, because again, when we are talking about bugs, again, there is a huge data that we can think about, because sometimes there are, after some time, like maybe after 1 year, 2 years, maybe we might have thousands of bugs or issues raised by lots of different people from lots of different stages. Some of them will be raised or created in production environments. Some of them will be raised from the testing environments. But eventually, we can make some classifications. Like we can classify them according to the creator, or according to the assignee, or according to the module or the component on which the bug was found. Like if the system is composed of lots of different subsystems or modules, or maybe even services, if it's a microservices structure, then we can classify the bugs according to the relevant service or the component on which the bug was found. So in that case, we can figure out what part of or what subsystem of the whole system is the most prone to errors, most fragile upon errors. So all these kind of classifications can be done again, of course, by the help of machine learning algorithms. So now I will share one example, one practical application that I tried in my project to just give an idea about how it works. In this study, there was almost 900 bugs. It is not a very huge number. It is not a very mature data set to be used in machine learning algorithms, but I want to go with the real data. So in my project, up to that time when I tried this study, there was 900, almost 900 open bugs, and there are three severity levels. Of course, there are some more, but in practice, what I had is three different severity levels, starting from 2, 3, 4. So, and if I had severity 2, because normally in the system we have severity 1 level as well, but that was the life issues like safety issues, and if there are any leakages in the hardware or electricity leakages, and if it can harm to human body or this kind of life related issues, we had severity 1 issues, and in practice we didn't have it. So I have 2, 3, and 4, and if I have severity 1 or 2 level bugs, then they were blocking the release. They were the release blocker bugs, but other 3 and 4 were not release blockers. So there was a important decision to decide if a bug, a raised bug, is severity 1 or 2 or not, which means 3 or 4. So this distinction we will talk about, and we can discuss how we can perform this classification. Let me introduce you what I did in the study. First of all, of course, I export all the bugs from our issue tracking system. In this case, it was Jira. And when I export all this, it was like an Excel spreadsheet, and it was having some string values, like just text values, because whenever we are raising our tickets, what we do is we just describe the issue. We put a title, we add a description, like, and we explain, we describe the situation, the problem. For example, whenever I navigate to some pages, when I click some buttons, and then the response was not the expected result, like, or maybe I encountered some internal server errors, like 500 response code showed up on the page. This kind of with some representation, with texts, some string values, we express our problem in the tickets. So what I have to do is I have to somehow extract the features, which means because this natural language that we are using in our daily life is not understood by the machines, we should change this. We should convert this text values to some numbers, to some numeric numbers. This is the feature extraction. But to do that, first of all, I have to get rid of the unnecessary information. So this is why I'm doing the pre-processing. I'm cleaning the data, and I get rid of all the data which will not be used or which is not necessary for the machine learning algorithms. And then I do the feature extraction. So in this regards, I use bag of words, like I count the frequency of the words in each sentence, and then in this way I can convert all the words to some numbers, and I end up with a numerical vector. Because if I count the frequency of all the words, then I can have an idea about the weight of all the words happening in the ticket. Like in some tickets, maybe I used a specific keyword a few times, like 500, even this as a text, the number 500 as a text is used a few times, then I can guess that maybe it's related to an internal server error, and I can do my classification or the bug triage accordingly. So after extracting the feature, I can feed all these features to my algorithms, and I use several algorithms to evaluate, like I used KNN, K nearest neighbors, or naive bias, or K-means clustering, and even random forest and lots of different SVM and lots of different algorithms. And I evaluated all the performances from these algorithms. And eventually, let me show you the results. I thought that there were three different classes, and the accuracy rate after performing all this was around 73%. We can see the confusion matrix here as well, but it is it can still be used in a real application. But I figured out I can even further improve, because let me go back and show the distribution, because there is a bias on class 2, right? Because most of the instances or the tickets that I export was labeled with class 2, severity 2. So if I merge class 3 and 4, it can be a more balanced distribution. I can maybe get rid of the bias on class 2. And does it make sense? Why would I merge class 3 and 4? Because at first, as I explained, if a bug is class 2, then it's a release blocker, but if not, it is not. So even class 3 or not, 4 means it is not class 2. So merging class 3 and 4 would make sense for me in this case to decide if a bug is a release blocker or not. So this is what I did. And after I merged these class 3 and 4, I figured out the accuracy rate is now 82%. And this is the confusion matrix. We can already see it much more balanced compared to the previous one. And of course, not only classification, we can do the clustering as well. Like we can group all the similar bugs all together, and in this way we can manage easily, and we can maybe do the assignment to the similar people or the similar teams. So we discussed several stages inside the software testing lifecycle, where we can use or utilize machine learning algorithms in lots of different ways. We started from generating some test cases, and of course there are lots of different commercial tools or open repositories that we can use. I'm leaving some of them just for reference, but basically the activities that we discussed was generating test cases, and then generating the test code itself, and then executing the test suites, and then collecting some data during the executions and evaluating this data and trying to figure out some hidden patterns, like maybe the execution duration or some other metrics, and then doing the continuous maintenance, like the code review or maybe migration of code to other frameworks or other programming languages. So and eventually we discussed about managing the bugs. So there are lots of different things that we can use with the help of or the support of machine learning algorithms. So nowadays we are discussing a lot about maybe if we can replace the human testers or maybe even the developers with the machine learning algorithms, right? But maybe our conclusion would be, why not only make a collaboration instead of just trying to make a replacement? So if we use them in our test activities, we would save a lot of time, we would minimize the manual effort, and even if we do not replace the manual resources, then we can utilize them in lots of different improvement activities. Like maybe we can already let machines do the automation activities, but the manual resources can be allocated in exploratory testing activities and all the other improvement rooms that we can use in our projects and the products. So again, thanks for listening to me, and thanks for the organizers and the sponsors. And if you have any questions, I would be more than glad to answer. Again, I'm reminding the socials that you can reach out to me. And thanks for listening, and enjoy the rest of the conference.